Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com Roundtable, brought to you by Techstrong. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting panel ahead. First, I do have just a couple of housekeeping notes to cover. So today's session is being recorded. If you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we really wish that you do. We want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. For any other comments or thoughts, or maybe you just like to let us know from where you're tuning in, we want you to use the chat tab. And of course, before we close out of today's program, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's program. So our topic today is Kubernetes on the edge. And I'm joined by Zach Kazansky, Vice President of Software Development at High Velocity, Ivan Fetch, developer at Fairwinds, and Mike Vizard, Chief Content Officer here at Techstrong Group. So Zach, Ivan, and Mike, thank all three of you for joining me today. Mike, do you want to get our conversation started?
Great. Thanks, Cody. Hey, guys, welcome to the show.
Thanks.
We hear a lot about edge computing, and we also hear a lot about Kubernetes. But Kubernetes, for the most part, has always been associated with cloud native and the cloud. So, Zach, bring us up to speed a little bit. What exactly is driving the convergence of Kubernetes at the edge? What are the use cases that we're going to see evolve that really require something like Kubernetes to be deployed at the edge?
Sure. Thanks, Mike. Hello to everybody. So Kubernetes at the network edge, the first thing we have to ask ourselves is why does the edge even matter, and what is the edge? So I think
All right. I think we lost Zach for a second there. Give him a few seconds to come back in and hope for the best. Ivan, you're there, right? I can see you.
Yep. I'm here.
All right. Well, Ivan, do you want to take a shot at that question, and then we'll come back to Zach?
Sure. So I have a little bit of a different sort of approach from the other end, perhaps, of that question. So what's driving Kubernetes deployment to the network edge? I think on a high level, it is helping apps to be stable in environments that are less stable. So Kubernetes has been around for certainly a little while. So has various environments at the edge. But I think folks are having increased experience with Kubernetes successfully in other environments. It's becoming more prolific. And so teams are naturally gaining more comfortability and experience and maturity with their application and operationalization of Kubernetes. And so that helps folks to be ready to tackle Kubernetes at the network edge as both their perspective and Kubernetes itself has matured.
Do we think that there are multiple flavors of the network edge? I think sometimes we use this term to kind of ubiquitously describe everything and anything. But in the context of Kubernetes, it seems like we're talking about really just at the edge of the network where we're going to load some applications and have some processing. One of the things that seems to come up a lot is we're kind of changing the way we think about IT. We're starting to process and analyze data at the point where it is being consumed and created. And so, as we think about Kubernetes at the edge, do we need to think a little bit more about specifically where and where it makes sense? Because Kubernetes can't be, I'm not going to put that out at the edge of my phone per se. So, do we need to think through where Kubernetes sits at the edge?
Yeah, I think that as we're going to continue to dig into as a common theme throughout this webinar, I think that the edge is a very general term that has a lot of variation. And it's that variation that is really where things are going to matter as folks are considering whether and how they want to use Kubernetes to help host and heal their apps at the edge environments. So I think that, like you say, there are likely certain edges that today, like your phone example, where it's two on the edge, probably, right? We're not going to have everyone's phone be a node in a Kubernetes cluster today, although that's a thing that certainly sounds like a fun a fun thing to consider, right? Maybe the Kubernetes control plane being more forgiving in the future and more flexible, we could do something like that. But I think that's probably going a little too far, but it certainly sounds like a fun side project.
All right. So one of the benefits we get with Kubernetes at the edge is that the consumption of resources becomes easier to manage, and you can scale things up and down more easily, and you're not necessarily required to provision for the worst case scenario all the time. You can allow for some flexibility in the process. But from your perspective, Ivan, what makes deploying and managing Kubernetes at the edge challenging per se than your average instance of Kubernetes that we might see today in the cloud? Are there certain attributes about it that are different that we need to think through?
Yeah, absolutely. I feel like this is a huge topic that is where most of that variation that I referred to earlier lies. So I think that the quality and the reliability and the uptime of things at the edge are much different than what folks tend to expect in most data center environments and certainly most cloud environments. So, for example, you probably will have less stable or more intermittent access, both from a network perspective. So your network might not be always on, or it might be sometimes more latent than other times. And then that stability of access or intermittent ability to access also extends to the physicality, the reachability of a site, everything not being in a handful of data center locations and instead being out at these sort of spokes of a wheel of your business, all these different edge locations, whether they're restaurants or stores or whatnot. They're not always going to be easily accessible. And then you also have a lot of potential differences that you're not able to achieve uniformity across all of your edge sites. So the standards by which we would build data center environments, of course, aren't going to always be achievable at edge sites. And even one edge site to another is going to have variation in things like network, like I already mentioned, power, cooling, and even configuration per site. So what if you have a slower network at an edge site that's maybe not in a city, maybe it's more rural. You might have configuration differences at a site that is more small town than a site that's part of a metropolis. And so that's all going to impact the needs for the site as well as the resources and the space that you have available at that site. So there's the last piece I have here that I think is interesting and different about this is that physical security at the edge is a lot different than the physical security of data centers. Data centers tend to have security protocols, access protocols, requiring you to sign in if you're a vendor that's visiting and be badged, and maybe you're escorted. There's cameras. The network is protected at a physical level as well as at a software level, and that's not necessarily the case at edge locations. So you never know who may be able to connect or plug in or access wirelessly some kind of network that's very close, very adjacent to the Kubernetes clusters and applications and data that you have on site. So I actually have a lot more points to cover because this is such a broad question. But let me pause for breath here and see if I'm not sure if Zach's back with us.
All right. Hey Zach, how you doing?
Zach has sprouted brown hair, and he's a little shorter than he was before. So I'm Rick. My name is Rick Nicholas. I lead strategy at High Velocity. Zach had to step away for a second, so I'm gonna step in and cover.
All right,
Zach and I worked hand in glove. So in my biased opinion, you'll be in good hands. I still think it's worth listening to. So anyway, it's a pleasure to speak with you both. Really excited.
Yeah, sounds good.
Well, welcome aboard. So we were playing around with two questions, and we've gotten some questions from the audience. So I'm just going to kind of mash them together in a way that you can answer the audience question and the original question that we were playing with. But and Ivan took a shot at this earlier. But we do see so many types of things on the network edge. So we were discussing where exactly does it make sense to use Kubernetes at the network edge, which led one of our attendees to ask the question is, so, what are the criteria to consider for deploying Kubernetes at the edge? And, are there attributes to the nodes that I should be thinking about? Like what exactly, how much compute resources do I need to drive Kubernetes at the edge? And that kind of defines where you're going to put it, right?
There's a couple questions in there. So what we try to give, we think about, let me take a half step back and answer the question a slightly different way. So when we think about Kubernetes, the way I understand it, not as a developer, but as a business person, is that this is a technology that is really born out of the public clouds, sort of a method to move workloads around and sort of package them up and easily move them from A to Z. The revolution, or sort of the big news, is that now that technology has made its way down into what I would call an infrastructure agnostic setup. So now you can run what I would call cloud native workloads on bare metal. And why does that matter? Because it matters for all the reasons that bare metal, has an advantage in some ways over the public cloud in terms of cost, in terms of nimbleness, in terms of egress fees, which can matter at scale when you're talking about putting workloads closer to where people are. The other big difference is that when you build, public clouds are built sort of in a campus and regional setup. So US East, US West, US Central. And so you don't really have a lot of pinpoint accuracy in terms of where your workload might need to live. So for us, if you need to put a workload in Mumbai or Pune or Delhi, you can pick. You don't just have to pick Asia East. And so when you combine the geographic sort of pinpoint nature of putting servers somewhere, plus the ease and sort of the drag and drop or programmatic use of moving workloads around with Kubernetes, that feels a bit powerful. But then to dive down into what are the minimum hardware requirements, I will only speak for myself in my bare metal view of the world, which is to say any server that would be sufficient, powerful enough to be considered a bare metal server, which is just a physical 1U box, would be powerful enough to run Kubernetes. These things are not, the individual workloads are not terribly large. The question is, how big do you want to scale? And then we can talk about a different conversation there.
There you go. We've been talking about distributed computing as long as I can remember, and it was never easy. So here we are talking about even further distributed computing out to these various edge platforms. Is it going to get simpler, or do I really need to be a rocket scientist to kind of deploy applications at that level of scale out requirements? Because, all these things are very latency sensitive, shall we say, or is there a smarter way to think about it?
I certainly don't think that it's been getting easier overall. I think it's been getting more complex because when you distribute computing more and more, it adds complexity to the deployment and the management and the troubleshooting of applications. So it adds challenge to that. I do think it's true that the ways to deploy apps, especially in Kubernetes, are improving. But along with that, I think we've seen a lot of abstractions also come to town, which are great, but it's often a double-edged sword. So it's for sure easier to create a Kube cluster these days than it was a good double handful of years ago, especially in cloud. One of the things that Rick had said earlier about Kubernetes kind of being born in the cloud, I think my opinion is it was born, sort of everywhere, but I think cloud really helped Kubernetes to be usable by folks because they didn't have to deal with the foundation of their data center, their network, how things were set up in compute racks, and how do we load balance in the data center in a way that's integral with Kubernetes? All of that stuff came it's kind of ready for use in a way with cloud, such that people could click a button and spin up a cluster. So also I think depending on how distributed that compute is, getting back to kind of the core of your question, the security and the compliance stuff becomes a lot more complex. So you end up having things like multi-region hosting of infrastructure for customers, needing to also care about where customer data lives for data sovereignty and those sorts of things. So with our distribution brings a whole host of issues that we have to also make sure that we're addressing. So is distributed computing getting any easier? I suppose if we focus in real narrowly and we just look at the distributed computing part, yes, like things like Kubernetes are helping us to build platforms that are going to fit our business, and that's definitely getting more straightforward. But if we care about what sits on top of the distributed computing and our ability to deploy, manage, and troubleshoot, I think that's certainly very complex.
Yeah. Rick, do you agree with that? I mean, and I'm going to ask the follow-up question, because in effect, is Kubernetes creating, an opportunity to apply the same models that we use to manage IT in the cloud out to the network edge? And in effect, are we creating a lot of what people might refer to as micro clouds, and we need to just think about managing them in that same kind of motion, but it's just a different place? Is that kind of the shift in mindset, or is edge computing just fundamentally always going to be different?
No, I don't think it's fundamentally different. I think a lot of what we're spending time on as a business is making ourselves indistinguishable from a usability perspective. I always talk about, this is the business guy, but I talk about dragging and dropping a workload from AWS East to high velocity in Fort Worth, Texas, for example. And in order to make that happen, there's a tremendous amount of work around code and automation that has to happen on our back end to meet the standard that's been put forth by the public providers. And so our vision is one that that geography and nuance drives where the workload should live. So if you need to be in Fort Worth, then hopefully you'll come to us, but it shouldn't be a technical limitation that drives it. And so all that to say, a different way of answering your question is that we're seeking to make it simpler. And we've seen a number of firms, by the way, that are not in the infrastructure business, that don't own thousands of servers like we do, focus on the software side of making things easier. So we have some partnerships that we'll be announcing in the future with some firms that own no servers, but only own code, and who focus on what they call managed Kubernetes, and basically making this process simpler. And then when we think about our go-to-market, the last thing I'll say on this topic is we work hard to partner with firms like that, whose job it is, like Ivan said, to abstract the underlying infrastructure. We don't think a customer should care about whether it's on AWS or high velocity or anywhere else. We think that they should care based on latency, based on cost, and based on data sovereignty compliance. Those are just three things that come to mind for their factors of decision making. And so within that, they should be able just to move the workloads around where they belong based on the constraints of their code. And so we're working really hard to partner with firms that deliver exactly that experience to customers. And it's coming. The simplicity is coming fast. There's a lot of money being spent on the business side to deliver that to folks.
No. Ivan, do those applications wind up becoming more stateful than the first generation of applications we might have seen around Kubernetes, where everything was kind of stateless? So are we going to see more processing of data at the edge, and therefore we need databases and other things at the edge as well that's got to sit on top of Kubernetes? Or are all these things going to be, for the most part, continue to be stateless?
I think that we're seeing more stateful apps go into Kubernetes in general. And you and I, not too long ago, did a webinar on exactly that. So I won't repeat a bunch of those pieces, but I biasly think that that was a good webinar. If folks haven't checked that out yet, stateful apps in Kube. So because there's more apps going into Kube that are stateful, I think it also follows that businesses need their data accessible at the edge as well, as you said, Mike. And so that, we're seeing more apps in Kube with state, and therefore we're seeing them at the edge as well. I think one tenet of a lot of edge Kube architectures is that even though you have independent edge locations, they still need local caches of data that comes from a central location. So whether that's awareness of orders or customer records or some kind of scheduling that has to do with humans, not with computers, you want to make sure that information is available at the edge as well. So even if it's not the primary source of truth for that information to live at the edge, it has to live at the edge as a cache. And that cache might only be occasionally refreshed depending on the quality of the network access between that edge location and the central storage. So I think you end up having this category of stateful apps running at the edge on Kube, even if they're only caches and they're not long-term authoritative. They still matter a lot to have that high-quality customer interaction at those locations.
All right. And then, Rick, bring that back to the previous question. Is that part of what makes it easier to do distributed computing at the edge? Because we're not trying to drive everything back to the cloud per se. We are processing data at the edge. We are using caching techniques. And I'm not, trying to send all kinds of raw bits back over a pipe somewhere in a wide area network to a cloud service per se. But I need to think about this from an architectural perspective because it's not easy, right?
Yeah, that's right. Ivan said it well. Not every workload looks the same. In fact, I don't know which percentage more or minimal, but yeah, I mean, we think it's more frequent that folks are going to need stateful compute than stateless. When we think about what our customers want, we've seen really post-COVID, we've seen an explosion in consumption like this. And it drives me to a use case conversation around media and entertainment where maybe you're online gaming, maybe you're distributing live video. And those are things that require a more persistent state, I would say. Of course, this has been happening for a long time, by the way. We should take a couple steps back. And I think back 10, 12 years ago, I live in Tampa, Florida, and it was big news when Netflix put 10 racks in downtown Tampa to basically cache. And back then, downtown Tampa was an edge site, and now we're talking about putting compute, in cell phone towers or even in retail stores. And so this is a trend that has been happening for a very long time. As more and more content gets consumed on a heavy way, like at my house, it used to be my fiber connection. Now it's my phone. One of the reasons I try to have the latest cell phone is so that I can consume a ton of data on that phone. And I do that because I like to see what use cases are going to build up around that, because those are probably going to be my customers one day. And so anyway, that's a little bit of a 2-minute diatribe, but this is a trend that's been happening for a long time. We, as those who control the infrastructure, are just coming up with ways to more effectively manage it. But I think the job remains the same: simplify, simplify, simplify. Solve the problem for the folks who are trying to do it. And you solve it by making it simple. So yeah.
Well,
the thing I
speaking
like about the microcloud question, before we kind of move more away from that one, Mike, is that I think it's helpful to look at a lot of these edge locations as clouds tend to refer to availability zones or regions, or to put it another way and somewhat more generally, essentially the edge is some kind of failure domain as it applies to your central infrastructure and even to other edges. So I think you've got all these independent clusters living at the edge, and each location is certainly autonomous, similar to an availability zone or a region. So whether that's the cache layer that we've been talking about, whether it's like Netflix caching in Tampa or other customer data being cached at edge locations, or whether it's processing data at the edge, aggregating it up perhaps in some kind of a way. Mm-hmm. And then, so like you said, Mike, not always having to shovel bits constantly back and forth to a central location, but doing some data aggregation helps you save on bandwidth, helps you save on latency and being able to process some stuff at the edge such that it helps the customer and helps your business, and then shuttle things back and forth. And one of the things that I think that applies to that's very common from an infrastructure perspective is things like logging and monitoring, for example. So you don't want to constantly be shoveling monitoring data and application logging that you care about that happens at the edge all back to a central location. And you probably won't be able to constantly do that. Like your network availability might not be always as reliable as you wish it were. So what ends up happening is, if you're using something like Prometheus and you want to have a local Prometheus instance aggregate data and then shovel that up in chunks to a central location, we see things like that happening from the monitoring and logging perspective. And then going in the other direction, how do you centrally get information about your clusters or their workloads or how they're operating or their health and so on and so forth when there's these clusters that are distributed all over the place? So there's a similar problem to solve there. Do you have some kind of encrypted endpoint that connects to your cluster, but you don't want to be having to constantly query these things out at the edge, right? So you need to architect some kind of telemetry so that you've got perhaps a little bit old, like maybe not right to the second, but some kind of telemetry coming from your endpoints at the edge, that when you're interested in looking at trends or how the health of your apps have been, you've got that data that doesn't rely on real-time access to those edge locations. So those are some sort of anecdotes that I think apply really well to folks on this webinar that are thinking about it from the infrastructure perspective and help kind of fit in with the analog of edge locations being failure domains in the cloud.
So one of our attendees is interested in how automated can all of this management of Kubernetes at the edge get, because most organizations probably can't afford to, physically send people out to every place that they're going to drop a cluster. So how do I provision that? What is the management of that going to look like? Rick, can you walk us through what is the state of the art for automating Kubernetes deployments, provisionings, updates, and all that good stuff?
I would tell you that the physical logistics is our core value prop, and it's probably a 1-minute answer. So I'll talk about India again. It is very difficult to get servers into India and then to deliver them as a service. So if you as an enterprise were interested in expanding there, I would argue you have to have a lot of servers before it makes sense to figure out how to do that yourself. And so one of the value props that a cloud provider, High Velocity or anybody else, offers is especially in hard to reach places, is just the fact that the gear is there, landed, and accessible from the internet. So that's the first thing. If you're comparing it to a firm doing it themselves, I think there's a large gap between doing it yourself and hosting it, especially when you're talking about an edge type site. That's the first piece. So once the servers are there and connected to the internet, the next question is, what's the state of the art as far as deploying them? I think if I were to walk back to my DevOps team, they would probably all have different answers about that. So I think our broad approach tends to be one around agnosticism. Like, I don't want to pick. So we start with our API that allows people to write their own code and deploy it that way. And then we layer on what we see as the most common sort of abstractions, be it Terraform, Cappy. Those are just two that come to mind. I'll probably stop blabbering before I put myself in a corner. But so we try not to be opinionated as a hosting provider. We try to be neutral and let folks plug in their preferred manner. Therefore, I will not be opinionated.
All right. Well, Rick said the magic word as far as we're concerned, DevOps. So what is the state of the art for DevOps in these environments? How easy is it to, for example, to roll something back if I roll it out and for whatever reason there's an issue? Because it seems like, do I have to send a crew out if I mess up, or is there some way to kind of bring that all back or restart it? And what does that look like?
I think it's gonna, unfortunately, the it depends answer. So I'll try to fill that in though as well as I can. I think it's going to depend a lot on the architecture, and I'll mention a few bullets that are the most important to this being successful. So testing rollouts as much as one can before that actually starts happening at edge sites is paramount to this. That feels obvious to say, but there's also a lot of variation that can happen from edge site to edge site. Like I mentioned towards the beginning of this webinar, where you might have configuration differences because the edge site is a previous generation of design, or the edge site doesn't get as much attention for whatever reason, or maybe it's a less busy territory and whatnot. So it's easy for us as practitioners of this to miss some of those corner or edge cases where 90% of our deploys were successful because those edge sites are to a particular spec, but this is the edge site that didn't have as much storage or doesn't have as good of a network link, or the network link drops out, and so it interrupted some of the rollout process that we're doing. So it's going to depend a lot on those kinds of factors. So the complexity, the amount of testing that happens for your deployment, and then the competency of teams involved, which doesn't just mean the team perhaps sitting at a central location doing the work. If you do need some more physical assistance at an edge site, it's not like a data center where you have remote hands available necessarily to help with things. Who are your remote hands at edge sites? Is it somebody that kind of on the side helps occasionally with the drive replacement or something like that? Because as we know, the cost of a roll out to an edge site to scale up equipment, replace a drive or a failed power supply or whatever is much different. Companies are certainly used to doing this. There are businesses who this is their business to do fixes. But if you're a company who's used to working in a data center environment and you're switching to edge locations, this is also related to some of the points that Rick made earlier around the cost of getting spun up in a region, the cost of changing or scaling your environment is much different in edge locations than it is in a data center. Saying something that's easy that we've said a lot in data center environments, like, oh, we're going to add some disks to these rack of servers, no problem. Now all of a sudden the scale for doing that in an edge location is much bigger. So I've digressed a little bit to kind of backfill some of the other topics that we've been talking about that relate to this. But to get to your core question about rolling back, I think it's going to depend a lot on the complexity of those edge environments, how much testing went in, and what's the level of competency. And as far as sort of the DevOps abilities to help make this happen, I think that's also going to be pretty architecture dependent. But we know we have a lot of great tools out there. We know we have a lot of infrastructure as code type things that will help. Like, for example, I think GitOps helps a lot in this space. So you don't necessarily have to have an active connection to a site in order for something to apply. You can update it in a central location, and then when that site's able to check in, it can go ahead and pull the updates to your repository and apply more locally those updates. So I think resources like that go a long way to helping some of this update and deployment stuff to be more asynchronous.
Rick, do you want to add to that? Because you mentioned that your DevOps guys would give you all different definitions for different things. So do we need like a new DevOps at the Edge manifesto with a cloud native spin on it? Or, or can we just all go along our merry way? Or do we need to take a minute and kind of take a step back and say, what is the smartest way to go do this thing?
I think it's early. And so I think these things will play out like they always do in the space where the best product will win. I think right now we're just in a place where folks are opinionated, and like Ivan said, it's architecture dependent. I mean, without naming specific customers, I'll say some of the largest online gaming companies in the world, or gaming companies in the world, period, use CAPI. Others use nothing, meaning it's still being done by hand all over the world. And then, of course, there's folks in the middle that will say, use Terraform. And so I think it's too early. And so I think to deliver a manifesto or to be extremely opinionated would leave some workloads on the table for others who are not opinionated. And so, no, I'm not I continue to not take a hard stance. I will not take the bait. But so again, we build it in a way. And if you want to build your own, by the way, like if you want to do Cappy or Terraform, good on you. But if you want to build your own and just connect directly via API, we offer that to folks too. So again, not to make it about us, but just what we've seen in the world is that taking a stance won't serve you well. I mean, there's some other, I would say, subscale public cloud providers that have tried in the past with efforts like OpenStack and others to say that we are the OpenStack cloud. This is the wave of the future. Come on, and that didn't go well for them. And so we don't want to make the same mistake.
All right, Rick's all about the freedom aspect of the thing. All right, here we go. Ivan, we have a question that someone's asking, and it's one of our topics, so I'm just going to shift to it anyway. But the question from one of our attendees is, how do you make Kubernetes immutable and tamper-proof at the edge? And we have security as one of our conversations as well. So how do we secure these things in a way where we don't have to worry about somebody showing up at some physical location and messing with the infrastructure or trying to download malware onto these things? What does the security aspect of this look like?
Yeah, there's definitely a higher threat level at the local edge than the data center. And I touched on a bit of that earlier in terms of the potential network access and like you said, physical access. Such as who will connect closer to your network and therefore your cluster and your workloads. I think that among the security practices that are already happening and already recommended that they extend to the edge, I think container scanning and signing helps you verify that you are running the containers that you expect to be running. That's one thing. Also, I think not exposing too much to the local network that isn't necessary to expose, like node ports from the Kubernetes nodes themselves, or obviously access to the nodes themselves. That access can happen over some kind of encrypted link, which could be routed completely differently versus opening ports on a local network itself. And then the last thing that I think applies well to this is that the practices that we also will always recommend in other non-edge environments that particularly help here that have to do with that physical access are remember to encrypt at all sorts of layers. So what do I mean by that? You've got disk encryption itself, so that if somebody comes and grabs disks, you can't mount those disks on another system. You want to make sure that you encrypt other things at rest. So in Kubernetes, you've got etcd as your kind of quote unquote database that's holding all your Kubernetes resources, and you want to encrypt your secrets at rest and etcd. And if you do that after the fact, you want to make sure that you take the time to re-encrypt existing secrets. So enabling secrets encryption in etcd doesn't encrypt the secrets that are already there. So make sure and do that. And then also encryption of all sorts of network traffic. So you have, let's say somebody did gain access through an application, a more traditional threat vector that we often think about. You can use things like a service mesh to do mutual TLS between your applications, besides encrypting things that are egress and ingress for your cluster. So making sure to use TLS with your Kubernetes ingress resources and so on. So I think those things go a particularly long way. They're always important, and they're always the things that we mention as good tenets of security in things like containers and Kubernetes. But I think they work, or they're particularly important in this landscape because you have that different physical threat model.
Yep. I'd like to add to that, Mike, if that's okay.
Sure, go for it.
Yeah. So one of the, as a service provider, the provider of the infrastructure, that's the seat we sit in. One of the questions we get asked sometimes that I didn't mention just because of our different seats on the table is a customer will ask, well, how do I protect and secure my server from your staff? So, do you have background checks and all that? Well, sure we do, but ultimately, how is the customer server going to be protected at the edge or not, even just from a rogue employee? And the answer we give them is around physical encryption of the hard drive. Even if someone were to get access to the drive, if it's encrypted, it's going to be, your odds of compromise are much lower. And I just wanted to offer an anecdote around that because it just given my different seat, it's a question that customers ask, and I think it should be asked. Like, how do you trust the infrastructure provider? And we tell you don't have to trust us. Just encrypt it so that we have no ability to access. And yes, and the other thing I would add, the final anecdote is when you compare, let's say, Los Angeles, One Wilshire versus somewhere in Seoul, Korea, or Sydney, Australia. One of the common ways that customers will ask about and sort of check the box, which is not sufficient, but it's what they do, check the box around security, is they make sure that the data centers themselves have an SSAE 16 certification around physical security. Well, like Ivan said, if your retail store is not going to have that, and so how then are you going to secure the machine if it's not physically secure? And so I wanted to put it in a bit more of a stark term for folks as a challenge around the edge. And for us, the answer is encrypt the drive. But certainly there's other work to be done as well. You can't just rely on the physical security anymore.
I'm glad you brought that up because you don't know necessarily who is in proximity of equipment at all of these different edge locations, right? Mm-hmm. People have access to knowledge, interest, tools. It's not necessarily that difficult to do things that we would never imagine doing. We're used to saying in the data center context, that's not possible. Nobody would be able to do that. And that doesn't mean that we should be thinking that way from a data center perspective either, because
that's right.
There's always levels of potential threat there. But I think they get more clear in these edge scenarios where even your own employees, even from a well-meaning perspective, are helping in air quotes, right? By I just reboot this, or I just reset power whenever things are slow. I'm helping our customers, but what else are they doing? So yeah, that's a great point.
All right, so I think you guys said expect the unexpected. Rick, the next question comes your way, and it's can mere mortals really do this, or is this something that you're going to contract more of a managed service type of play? Because for all the things that we just went through, whether it's security and the physical location and the performance and the storage, it seems like it takes a small army of specialists to go do this. So, what are you seeing? Are organizations going to really do edge by themselves and manage that, or are they going to lean on somebody else to do it for them?
Yeah, so it's a great question. So prior to my time at High Velocity, I spent about 11 years focused primarily on co-location and then managed services. So I've worked my way sort of up the stack in terms of complexity. And what I saw sitting running a data center business for 10 years in the late 2000s and then early aughts was this shift from the enterprise being my data center customer to the service provider becoming the data center customer. And so that's a slightly long-winded way of saying I think that most workloads will be run in a managed way as opposed to being done directly by the enterprise themselves. A different way, I said the same thing in a different way with regard to the anecdote of trying to get your servers into Brazil or India. It's very complicated. You need a lot of subject matter expertise in order to make it make sense financially to do it yourself. I would argue it's very much the same way for just any given company. This is complicated work. It continues to be complicated work. And for most of these firms, they're not in business to manage infrastructure. They're in business to deliver content. They're in business to do online gaming. They're in business to deliver autonomous driving. They're not in the business of managing infrastructure. And so, again, over the course of my career, I've seen more and more workloads move towards a managed and towards a service provider-driven path. And I don't think that's slowing down at all. If you were to ask Digital Realty Trust or Equinix who their customers are, they would tell you that by and large, they're service providers. And so that's who we sort of aim for when we go to market because we try to play along the same path. I think, of course, when you're of a certain size and scale, it could make sense to in-house it, so you're not paying that premium. But I think you've got to be awfully big to justify it. And I would just add as another sort of pitch for the service provider folks, you don't have to be that big to justify the premium anymore. There's a number of firms out there that really make it easy, and they abstract it so much that just, hey, put drop your code here and it just works. Well, for a lot of companies, that's enough, and that can be with a site as simple as a WordPress site or an online shopping cart all the way to something very complex. And so the abstraction is there and available to folks. My advice to companies when I talk to them is to get help.
Hey, Ivan, follow up to that. If I look back into the history of time, maybe 20% of IT has been consumed via managed service provider. As we get to this more increased complexity out there and we start pushing things to the edge, do you think that will shift more where, to Rick's point, we will see more and more of this consumed as a managed service? And is that will edge and Kubernetes and cloud native kind of force the issue?
I think that companies are figuring this out in parallel, and it's happening, and it has and is happening. So yes is my primary answer to your question. I think that the industry is working on this, and to Rick's point, and I agree that ideally businesses don't have to focus on this type of stuff because it's not necessarily their business. Although we have seen businesses still choose to focus on it and want to understand it very deeply because of how much importance these technologies play as a foundation to their business. And so we see a mix of both. But I think that no one size fits all, and that's part of the challenge here. And also, even though those abstractions really help, the abstractions also add their own complexity, right? It's sort of a joke, like, I hear you like abstractions for your abstractions kind of thing. So I think each company's developing this in their own way. And I think that the snowflakiness of a lot of customer data center environments is just snowballing. It's 10x for edge environments where there are, I'm not saying that people's data center environments aren't unique. Sometimes they are, sometimes we want to feel like we're unique, but I think that the realism of that really amplifies everything in edge environments. So I think that all of these things are going to continue to be true. I think that getting back to your questions, that yes, we do have the skills. Not everybody's going to want to focus on it. I think that there will be continued managed service provider type opportunities that are fulfilling this at the edge as well. I think we're already seeing it happen. Being able to move compute and processing and storage out to the edge in an integrated way with cloud and hosting environments is proof of that.
Rick, do you think that we may someday see more workloads out at the edge than we currently see in the cloud? And can we actually cope with that? Do we have enough people with the skills, even with all the automation that's out there? Can we, or is the demand and our technical appetite moving farther than we're able to keep pace with?
I don't think, as someone who would like to see more workloads at the edge, I don't think that we're going to see more workloads at the edge than in the core locations. We'll pick on Ashburn, Virginia as the cloud. Like, I don't think that you're going to see more workloads spread out across the world, or I'm not sure how you measure it, but no, I think the sort of core application service provider model where you have, a big behemoth in the middle somewhere where economies of scale are massive, I think that's still going to make a lot of sense because of not everybody needs to pay a premium for the speed of light. Not everybody is going to deliver gigawatt scale. And so as a result, it just makes financial sense to keep the majority of the workloads in large concentrated places. Yes, there's a security concern, but we have multiple large concentrated places around the world. And ultimately, to make the world go around, you have to have cash flows. In order to have cash flows, you have to be able to operate in a way that's very efficient at scale. And I think the public cloud does well at that. I think they're still personally extracting a massive premium. If you look at Amazon's, published metrics, they're charging too much, but they can get away with it. And so I think over time that'll settle in. However, it still makes more sense. So no is my answer to your question.
Yeah. Ivan, what do you think? Do you think that we're going to be able to keep pace with all of this? Or maybe, who knows, will AI save us from ourselves someday? I mean, how automated can automated get?
I mean, aren't we supposed to put all of our hope in AI? So I think we have to say yes, right? Because that's the big.
We don't want to make them mad at us. Yes.
Right.
These are overlords.
If you're listening, we believe in you.
Yes, exactly. Exactly.
I mean, I think that it's such a. I'm trying to think of an answer that's actually an answer for you, because I think it's such a broad topic. I definitely agree with Rick describing a second ago, the challenges to everything moving out at the edge. I think that the security and the compliance pieces of sort of making edge locations full-fledged compliant data centers that meet all of these standards is going to also be another piece that will make it less tempting to just move everything out at the edge. There's advantages to having things be central, like Rick said. In terms of your latest kind of advent on this, or add to this, Mike, about are we all going to be able to handle this? I think that this is all moving in a very exciting direction. We at Fairwinds constantly are helping people, not only with our software, but helping them onboard into Kubernetes, and with day one and day two plus running Kubernetes successfully and getting their applications hosted. And so we're in the lucky position of getting to see not only the success of their business running on these platforms, but also we're getting to see transitions, right? As much as we hate graduating from customers, having them graduate from us on some level, it feels really, really good to see customers get on-ramped in a successful way, help save them from a lot of their pain, and then be able to take the reins themselves. And so that's an anecdote that I think of when I consider, is it possible for everybody to do all of these things? We get to see that happen, and it's really cool to see customers be able to say, we're good. We've got this now. Thank you. And then they move on. Like that's a huge success to us.
All right. Hey, Rick, there are multiple flavors of Kubernetes, and we should touch on this. There are at least 3, maybe 4 now, lightweight distributions of Kubernetes that are out there. Are these the ones that we're going to see deployed at the edge? Or for that matter, are the lightweight ones going to take over everything because I can run them everywhere and they do 90% of what I need to do anyway?
I don't know the answer to that question. Zach might, but I bet if Zach was here, he would say that he's going to give you the agnostic answer. But I don't know. I'm not going to. That's what I'm going to tell you. I don't know the answer to that, and I don't care, honestly.
All right.
As the infrastructure provider, I don't care.
Ivan, you want to take a shot at that?
You don't care what runs on top as long as it's using CPU cycles and memory.
Boom. There you go.
That's what I'm hearing. All right. Well, at least honesty's good.
Yeah.
I think it's happening, and I think it's inevitable. I think everyone appreciates a certain kind of minimal streamlining, purpose-built distribution and that kind of stuff. I think it hasn't been as necessary in the cloud world. Rick mentioned this at the very, very beginning of the webinar, how cloud essentially helped a lot of folks to onboard into Kubernetes in various ways. I think that these kinds of more purpose-built distributions are less of a thing in cloud for some people, but I think they're a lot more appreciated in environments where there are finite resources and things like exactly what we've been talking about here. So things like K3s or keys as just one example, where they've taken a Kubernetes distribution where they're not stripping out a bunch of stuff, but they're helping you to streamline the distribution, and they're also helping you to fast track certain things that you're going to want in your cluster that's not going to be living in the cloud. So things like load balancer providers and that let you tie IP addressing in with your Kubernetes ingress resources or load balancer service types in general, and using things like Helm custom resources if you want to go that direction to help you manage some of your app deployments. So those are all things that they've baked into keys or K3s to help folks get onboarded. And it doesn't mean you have to use those things. You can turn them off, but I think that folks are really starting to appreciate that stuff. And I think that it's going to just keep growing everywhere. If you could run with less in cloud and spend less on compute so that you can then grow, and the compute that you're growing into is also your business growing. I think everybody signs up for that.
Yes, I completely agree. One thing to add, just an anecdote again from the service provider seat, the same server is much more expensive to the end user per compute cycle in Tokyo than it is in Dallas. And so if you're trying to put servers out at the far edge, you need to be economical. It would suit everybody well to deliver in a way that's economical and light. And so from that perspective, yes, like Ivan said, whether you're running it in the public cloud or at the far edge, lightness is better just because you can save on incremental expense, which is always going to be a driver of value.
All right, guys, we got a couple of minutes left, so here comes the ultimate question. Rick, you have been made king of all things Kubernetes for a day. What's the one thing you wish you could fix with the wave of a wand or a royal command?
I would make it completely provider agnostic, meaning you just driven by things like latency, cost, and security around data sovereignty. I want that to be the driver. I don't want marketing to be the driver. I don't want long-term contracts to be the driver. I want workloads to be completely portable and to land where they belong. That's my wave of the wand.
All right, no sneaky APIs. All right, Ivan, this is the second time I'm asking you this question, so I'm thinking you've had time to think about
it. Yeah, well, my answer is basically the same. I do like Rick's idea of essentially more data-driven, sort of action-oriented stuff that can live in Kubernetes. Like that is a cool sort of like feature request build on, if you will. But for now, my answer continues to be, Mike, basically the same one that it was before, which is if I could contribute positively with my new magic wand, I would help enable the folks in all of the different Kubernetes interest groups and so on and so forth to help them continue doing their work. And that would take the form of time and dollars to help folks continue focused dev cycles on these things and to continue doing the good work that they're already doing. Getting to see some of these calls and decision making and things that come out of every release and all of the work that goes in by the folks who rotate through the different roles of helping to get Kubernetes releases out there and triage things in GitHub and so on and so forth is a really incredible effort. And so I really appreciate the work that those folks put in. And if I could send some kind of thing their way, that's how I would use it.
All right, cool. Guys, thanks for sharing your knowledge and expertise. I would just say one thing, watch this space. I'm pretty sure that Kubernetes at the edge is going to be the tail that wags that cloud computing dog before you know what happens. And we'll see what happens and goes from there. But Cody, I'm going to give it back to you and take us home.
Sure thing, Mike. Thank you so much, Rick and Ivan, for joining us today. And Rick, really appreciate you stepping in for Zach. So you came in on the fly and rolled in like a champ. So thank you so much for your flexibility there.
My pleasure. Thanks for having me.
Of course. So I'd love to remind our audience that this session was recorded. So following this program, you'll receive an email with a link to access that recording on demand, or you can also find it living on the Container Journal website at containerjournal.com/webinars. So we do still have those 4 $25 Amazon gift cards to give out. Our 4 winners are Raul S., Kelly B., Paul C., and Lucas S. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. So Mike, Rick, Ivan, thank you all so much for joining us. To our audience, thank you so much for spending time with us today. We do ask for just one extra moment of your time for a brief survey that should pop up as soon as we close out. But otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Everyone have a great rest of your day.
All right. See you guys.
See ya.